So we have Sara Schmidt, and you can see her title and experience on the front slide, but we're really excited to hear from her today to learn about, of course, we have many years of experience of imaging a planetary body from space. And so the group that provides support to this for ISS and Artemis 1 operations have a ton of experience doing this. And we'll hear from three speakers coming up here that have, we'll be speaking about various aspects of this experience. But Sara is here today to talk about 20 plus years of experience from imaging from the International Space Station. So take it away, Sara.
Hi, thank you. Can you hear me okay?
Loud and clear, and we can see your video as well.
Awesome.
Thanks.
Thanks. So I'm super excited to be presenting on lessons learned from more than 20 years of astronaut photography from the International Space Station. This is definitely more of an operational improvement presentation, so I'm excited to show what we've been up to. Next slide, please. So, as Dr. Petro discussed, the impacts imagery has on public engagement in science, and I'm really happy he brought that up. He showed Apollo 17 Earthrise image, and imagery like this has provided inspiration across the science community. So just a quick timeline of astronaut photography. There's imagery from the start of the manned space flights, Mercury and Gemini and the Apollo program in the 60s, and then the shuttle program, and now the International Space Station. And all of these together showcase more than 60 years of astronauts documenting their observations through handheld photography. People in our group, which is now known as Crew Earth Observations, have been providing targeting information to crew members starting in the shuttle program era in the 90s and using the framework developed during shuttle targeting. CEO, as it is today, was created for the ISS, and our group is now working to adapt the workflow to the lunar environment. Next slide, please. So what is Crew Earth Observations? It is pretty much what it sounds like. Crew members on the International Space Station use handheld digital cameras to photograph Earth. Each day, a CEO payload operator like myself will provide targeting details for ground or atmospheric targets of interest. And these targets are provided by scientists, educational and outreach organizations, disaster response, NASA Public Affairs Office or headquarters, the ISS Program Science Office, and crew members themselves. Currently, we have about 400 or so targets that could be requested, including planetary analogs, cities at night, atmospheric events, long-term glacial changes, just to give some examples. Next slide. So this is a high-level view of our current CEO Career Earth Observations workflow. And our main deliverable is the daily targeting message for the crew. So that's, we create a HTML, currently it's an HTML message that comes with textual information for each target and 3 lead-in maps. And targets are selected based on crew schedule, any reboost that might be happening, window constraints, the location of the ISS for that date and time. We also include cloud coverage to make sure it's not too cloudy, and sun illumination. So we want to make sure that any daytime targets are able to be seen in daytime, and then any nighttime targets are going to be dark enough for nighttime imagery. And each of those targets have the textual information includes purpose of the imagery, any type of background or additional information that the crew may need to know for just making sure they're able to obtain those photographs. And from there, we uplink our targets to ISS flight control teams. They send it to the crew. The crew uses our targets to take imagery, which is eventually downlinked, and we put it on our database, which is accessible to the public, and it's called the Gateway of Astronaut Photography of Earth. Next slide, please. So the workflow on the previous slide has changed since the start of the ISSCO operations. It started in 2000s. So thanks to the evolution of technology and continuous feedback and the long-term institutional knowledge and experience over the past 20 years has allowed for these types of improvements. So just looking at this target alone, this is a view of recent nighttime target information for Amman, Jordan at night. And it includes that textual information I was talking about with the visual cues, any background, recommended camera settings for this specific type of targeting, and these 3 additional lead-in maps, which follow the view that they should be able to see out of the window while they're targeting this information or targeting this area. And it didn't always look like this. So this has been thanks to decades of feedback from the crew and team members. And we've also been able to automate a lot of our operations because of the long-term practice that we have. And a lot of our CEO operations now run through scripting, which has been a huge improvement to our operational timing. So in the early days, they as the operators, had to call and verify coordinates and vectors and make sure that the weather conditions were favorable, where now we have the capability to pretty much press a button and have that information presented to us quickly. And our most recent improvement is the automatic generation of these photos, these lead-in photos. And this has saved us hours of operational time. So what used to take a full, like up to an entire day of operations now takes us 3 to 4 hours tops. And this has freed up our time to allow for some new developments. Next slide, please. So this freed up time has allowed for us to work on private astronaut mission targeting opportunities and the Artemis 1 launch, which we also plan to target the Artemis 2 launch from the ISS, and something that we call the CEO special sessions. So you can see a video of Jessica Watkins' special sessions of planetary analogs over Mexico. And these sessions include 8 to 16 targets over about 30 to 90 minute intervals to evaluate the time needed to transition from target to target. And we've also used that information or used these types of special sessions to request low solar illumination for that resemble lunar environments. And the flight teams out of Marshall have helped us develop accessible targeting formats for the special sessions to view the message offline and on the crew tablets, which actually brings us to our next slide, which is collaboration. So we've had decades of improvement in collaboration between groups and organizations. And our team itself has seen various scientific disciplines and backgrounds. So we've had planetary geologists, geomorphologists, data scientists, so many more. And this has not only been helpful to our team itself, but for the crew trainings that our group provides to crew members before they fly, and that's coordinated through the crew office. And these trainings include planetary analogs, atmospherics, geography, many more, and anything else that the crew may be interested in. They also have post-flight feedback sessions or debriefs where we take the feedback that they provide through this session and we apply that to our operations. So this has been extremely vital to making our targeting messages more crew friendly. So anything that can help them help us help them pretty much. And we've also worked with imagery teams. So Photo TV Group has helped develop camera camera settings for more difficult targets like the cities at night, the Amman Jordan target we saw on previous slides, and for time lapses. And they also provide us with training to better understand the cameras that they use. So our group works across science, crew, and engineering ops teams, which have helped CEO become what it is today. And this continued collaboration and communication is pretty critical for any type of preparation and success. So next slide. So that brings us to crew lunar observation, something that's kind of been hinted at the past few presentations. So we call it CLO, crew lunar observations. The CEO team is already using the targeting, development, and improvements from the past 2 decades to develop CLO. And you've heard the discussions about targeting messages for lunar photography. CLO is taking the CEO infrastructure and framework from the Earth views to lunar views. We're adapting the legacy and experience into a new domain. So CLO is utilizing the cross-department and cross-organizational connections made through CEO to obtain the science objectives for Artemis 2 and beyond. Next slide, which is my final slides, and that's all I have. Thank you. To the moon.